Okay, look here. Just now I have created my PV. Okay, PV was created /dev stv1. Okay, before added, I have not added it to VZ. I have not created any VZ. So if I use pvdisplay /dev stv1, so P is this physical extent was not created at now because it was not mapped to any VZ. So P was also not there. Now I have created a new VZ with the name VZ1 by using command VZ create, where that PV was added to this VZ1 successfully. VZ1 created. In that VZ1, PV is there, physical volume is mapped to this VZ1. Now I use PVS. So my PV, I am having only one PV, that is /dev stb1, that was in VZ1. Volume group of that PV is mapped to this VZ1. Okay, so my VZ1, I'm having my PV in this VZ1 volume group 1, and type is LV2. The attributes are a something, physical size like this. Now I use that PV display command. Now I want to see what are the details of that /dev stv1. I use that PV display command. Here if you look PVS, it will list the what are the PVs that are having and which belongs to which VZ. If I use PV display with that PV name, it will give the total displays of total details of that PV. So here my PV is /dev stv1. I have used the command PV display. Okay, so my PV name is /dev stb1, and it's that was in my PV is in VZ1. The volume group of PV was VZ1, and PV size is, look here, 1 GB, approximately 1 GB. Okay, next allocatable, it can be allocatable, that means that is allocatable. Next PE size, my PE means just said you physical extent. It is a chunk of PV, and it is every PV was divided into some equal number of PEs. Here 4 MB, 4 MB MIB is each PE is having each division was 4 MB. That division is nothing but PE. How many divisions are there? 258. 258 into 4. Okay, if you count it, so it is 1024 MB. So here we are having 1 GB. So 1 GB is 1024 MBs. So if you divide 1024 by 4, we'll get 258 PE. So total number of PEs we are having in this PV is 258. Each PE size is 4 MB. So that we can allocate. So that this LVM allocated the PE size by default 4 MB. We can change that PE size also. Later we will see how to change that PE size. By default, the PE size is 4. That means each PV was divided into some equal number of divisions of 4 MB. So that each equal number of division is known as PE, physical extent, that chunk of space is known as PE. Here my PE size is 4 MB. So totally I am having the PV size is 1 GB. So 1 GB divided by this 4 gives you 258. So totally I am having 258 physical extents in this PV /dev stb1. Okay, after that freeze 258, no allocated PV. If you allocate that PE, later it will be change. Okay, so what we have done is we have created a PV. That PV was allocated to VZ. Okay, now we need to create LV. Okay, LV with size, some size. Now I need of course I have added only one PV, so I want to make a logical volume with some 300 MB only. So for that I need to use a command PV create size. I need to mention the size. For that I need to use -L. So I'm taking 300. So look here, syntax is for LV, to create an LV, the syntax is, here it is. So look here, size of that LV, suppose I'm taking it 300 MB, 300 M -L, name of that LV, and from which VZ we are taking it, we need to mention it. So here in this case I need some 300 MB. So for that I am creating M, using M, and I need to name that LV. So simply I'm naming it as LV1, or you can, it is MV like that also. So from which VZ we are taking that LV, we are mapping VZ1. So this is the syntax: LV create hyphen capital L, mention the size in MB. If it is MB, mention M capital M. If it is GB, mention capital G, and name of that LV hyphen N, name is LV1, and from which volume group we are taking that LV1 VZ1 group. So enter. Now our logical volume group was created. Okay, check whether it is created or not. Okay, so simply by using lvs command. So lv1 is created. Previously I have shown you lvs. If I executed lvs, it is saying that no lvs are there. Now we are having an lv1. It was mapped to vz1. It doesn't tell about pvs, because of course I have used only one pv here. Generally in a large volume group we can have so much number of pvs. So it doesn't mention about that. So just it will mention vz. Okay, that lv, this lv was in vz1 group. Attributes are this. The lv size is 300m. Okay, these are other things, so we'll see later. Okay, now after creating lv, that lv cannot be accessible. So to access that lv, first we need to format it by using a file system. After that we need to mount that lv using some mount point. Okay, so first format it. So for formatting that one, I'm formatting that using ext4, mkfs.ext4. Okay, and the syntax to that one is mkfs. And look here, how to mention that lv. If next time onwards you want to mention that lv combinedly, you must mention from which volume group that it is. And the general volume group was in /dev folder. So /dev mv vz vz name and lv name. So my lv name is /dev. Now onwards lv name will be mentioned like this: /dev. My vz name is vz1 and my lv name is lv1. You need to mention lv like that. Simply don't mention it is lv1. You need to mention complete path of that lv. That is like /dev /vz1 /lv1. Now look here. So it was formatted ext using ext4 file system. Now after formatting it, you need to mount it on some mount point. So for that mount point, you need to have some directory. You can create a new directory, or you can use some old directory, but I am creating a new directory to better understanding. So I'm simply creating it as LVM directory. So simply /LVM directory. So new directory was created in /. If you want to check it, let's check. Okay, where it is. Look here, LVM directory is there. Now you need to attach this directory to this LV1. So you know the command mount. So you need to mention the device name like this: /dev and vz name vz1 lv1. Completely this path will address the lv name. So my lv name is /dev vz1 lv1, and the mount point name is /lvmdir. Okay, now look whether it was allocated or not. Okay, look here. So in general, how lv will be mentioned means it will be mentioned like this: /dev mapper, because it is mapping. This lv is mapping to vz. Vz was mapped from pvs. All pvs are mapped to this vz. From that we are taking a logical volume. So /dev, it will be appear like this: vz1 hyphen lv1 on which directory we have mounted it, /lvm directory, and type of the file system is ext4, and the options for that one is read and write. Okay, so if you want to access whether that lv was located or not, whether it was created, or you can access that one or not, check it. cd/ my lv name. Now onwards I will mention that using directory. So if you create some files there, file, so file, check whether it is created or not. Look here, file. So now this directory was accessible because it was mounted. So my LV was created and that LV was mounted with this slash LVM dir mount point. Okay, now check the details of this LVM. So if you use LVS, simply it will list what are the LVs in my system present. Okay, LVs. Now if I use LV display command for a particular LV, so my LV name is slash dev vz1 and LV1, sorry, LV1. Look here, it will look here, the LV path is nothing but LV name. LV path is slash dev vz1 LV1. The LV name is LV1 only, simply the LV1, but you need to mention path, exact path. If you want to mention LVs, don't simply mention LV1. And it is in VZ1. That LV1 was created from VZ1 volume group, and it is the UID, unique ID. We'll see later. And axes are read write. We can change the axis also, read write. Later we'll see that one. And the host name of that one is RHEL server. These are details of that host name, time, status. It is now available. We can change it unavailable also. You can deactivate that LV using LV change command. Okay, later we'll see. And LV size, the size of LV is MB. Of course it is not MB, MIB. MIB means 2 power, 2 power. It was the base of that in twos. Okay, if it is MB, then it is base in tens only. If 1 KB is there, 10 power 3. Okay, we'll mention like 10 power 3 means 1000. If 1 KIB is nothing but 1024 bytes. KIB means 1024 bytes. KB means 1000 bytes only. That is the difference between KB and MB. If you see a real, suppose some pen drive is there, it was mentioned like 8 GB. If you insert it into system, if you see 8 GB, but you don't get that entire 8 GB, because that is 8 GB is nothing but it was given in 8000 bytes. So if you convert it into gigabytes to GIBs, then that will be in 8 into 1024 into 1024. That is somewhat higher. So that's why that space is missing. So in real time that they were mentioned in GBs, MBs, but in system point of view, OS point of view, that must be in MIB, KIB, GIB. So that is the difference between I, that is simple I. Okay, simple I and MB, MIB, KB, KIB, like that. Okay, now look here, current LEs. How many LEs are there? 75 LEs are there. What is that LV? So every LE is mapped to every PE. PI size is already we have seen that PI size previously, that is 4 MB. So the same 4 MB was mapped to this LE. So here LE size also 4 MB. Of course we can change it, we'll see later. Okay, so every LE size, so LE is nothing but every LV is divided into some equal number of LEs. Every logical volume is divided into equal number of logical extents. Here my logical extent is decided by physical extent. My physical extent size is 4 MB, 4 MIB. So my 4 MIB is same as LE. P is same as LE, same map to LE. So LE size is also 4 MIB. So if you divide my entire size of this LV is 300 by 4, you will get 75. So total number of LEs in the my LV is 75. Here LE size was not mentioned because it was mapped to PE. So PE size is same as LE size. So understand that one. And segments, all these are, you will do some research on this. Okay, that's about how to create LV and how to partition, how to format it, how to mount it. Okay, that's it. Next thing is after this, now now sometimes it may require to extend volume group. Suppose if your volume group is some 1000 GB, now I'm having two LVs are there. One occupied some 60 GB, other occupied 40 GB. Now I want to extend the 40 GB LV. So I will check whether there is space in VZ. So VZ is having 400 GB only. So 100 for 60 plus 40, it was 100. So that was not sufficient. So now in that case, I need to extend that volume group. So to extend that volume group, you must have some PVs, existing PVs. If PVs are not there, you need to create PVs. So to create a PV, you must check whether there is a space is available in disk or not, physical disk. After creating PV, we will add that PV to this existing VZ by using this command VZ extend with that VZ name and that partition name. Partition name is nothing but PV create. Okay, we'll see. After creating that one, you can extend the LV by using this command LV extend this. Okay, we'll see that later. We'll suppose my LV size is my VG size is VGS. Now I need an LV size of, I'm having VG size with this one. My LV size is 300 MB. Now I want to extend my LV to 1.5 GB. But I am having here LV size is 300. I want to extend 1.2. I want to add one more 1. G to this one to in order to make it to 1.5 GB. For that, I need to check whether the space is available in this VZ or not. So I'm having 1 GB in 1 GB space in this VZ. Out of those, 300 was already utilized by this E1. So I'm having 732 MB data free because 300 is already over. Approximately it is 732. But I require 1.2 GB or 1 GB. 1 GB is required. So what we need to do is we need to extend VZ. So to extend VZ, first you need to create a new PV. Okay, PV creation is same previous case only. First we will check whether how much how many PVs are there. PVs only two PVs. So this PV is again mapped to this VG1. So again the PV size is 732. We require 1 GB. So for that we need to create one more PV. So PV creation is same as like that. P fdisk hyphen L sorry fdisk hyphen slash dev sdb. So check whether the space is available in that SDB or not. Sorry, I have made some mistake here.
హలో
హలో
ఇప్పుడు ఎస్డిబి కదా ఎస్డిఏలో కూడా యాక్సెస్ చేసుకోవచ్చా?
yes okay, you want that? Okay, I'll do that. I'm quitting it. I'll show you. So already my PV is from present PV is from SDB1. I can add SDA from SDA1 also. I will show that one. Fdisk hyphen L. So I'm having two hard disk here. Wait. Here the first hard disk name is /dev SDA. It is of 220 GB approximately. Out of those 20 GB, some portion is over. Of course, I am having some free space. I will show you. I'm having second hard disk as STB. Out of those, one partition is done. This partition is added to LVM, that is as PV. Now I want one more PV. I can create PV from here, or I can create PV from here also. So to understand you, I will create PV from here. So there is some free space in SDA. So now format that SDA as using fdisk /dev SDA. Okay. So check. I want to create a new partition from this. Okay, already 3 partitions are over. So now I need to use 4th partition, because you have already seen that one, SDA1, SDA2, SDA3 is over. So I'm using 4th partition. Make it as some extended, or whatever it may be. No free sectors are available. Wait. So just I'm not having any pre-space in SDA, so I'm again creating a new PV from uh, STB only, /dev STB. So check how many. Only I'm having one. Out of the 1 GB was utilized. Of course, it is having 10 GB, so I can have 9 GB also. Now I want to create a new partition. My partition is sorry, some PRE. You can use anything. Later we will modify that one, PRE to LVM also. So no, not an issue with that one. Second partition, my partition is, how much I need is, now check here. Already 132 cylinders are over. Now I start with 133. So if you enter it by default, it will take 133, or you can enter 133 like that. Okay. Now how much space I require? I require some 1.2 GB, but I want to add some 2 GB. No issue with that. Some space will be left. We will utilize that later. Okay, 2 GB. Now the regular partition was created. Now I want to change that Xcode to LVM. So which partition I want to change that Xcode? So I have created a second partition. Look here. So you need to change that code only. If you type other partition, that will change that other partition's name. So the Xcode for LVM is 8E. You must mention it. So Xcode was changed. Check whether what was changed or not. P. Look here. Second partition name and 2 GB and 80, that was changed. Now my PV was, second PV is also created successfully. Now I want to quit it by saving it W. Okay. Now update it by using partx command. Partx -a /dev SDB. So it was updated. Okay. Now you need to create PV. That partition you need to make it as PV. So /dev SDB2. Now new PV was successfully created. Check whether by using previous command. Look here, it was created, but it was not added to any VZ group. So what my task is, I need to extend VZ, existing VZ1. The size of this one is 1 GB. Out of those 732 was free. Now only the first PV was added to this VZ1. Okay, now I want to extend this VZ using VZ extend command. VZ extend. Okay, which VZ1. Of course, in real time we are having a lot of some number of VZs are there. In my example, I'm having only one VZ. Sorry. Now I need to add this new PV to this existing VZ1. So for that, the command is VZ extend existing VZ name and newly created PV name STB2. So that VZ, that PV, newly created PV was successfully added to VZ1, so that VZ was extended. Check whether that was added or not. VZS, if you use command VZS. Look here. So the size is 3 GB. Previously, the size of this VZ is only 1 GB. Okay, out of those 300 was consumed by NLV. Now it was 2.72 was available. That's how we can extend a VZ. Simple, very simple. How to extend VZ is simple command. VZ extend and the name of that VG, which VG you want to extend, and name of that PV, partition name. But you need to check whether that partition is available, that PV is available or not. If PV is not available, you must create a new PV. Later it will be added to that one. Now I want to extend LV also. LV to, right now my LV size is to 300 MB. I want to add 1.2 GB to that one. How to do that one? So already we know, if it is a standard partition, we cannot extend that partition, but here it is an LV, large scale volume. So here this mount point can be extended, and one more advantage of this LV is we can do that online. Online means without unmounting that mount point. Here my LV was mounted to /LVM directory. So if it is a regular standard partition, if you want to do some work on it, change that partition, you must unmount that mount point and unmount that mount point, and also do the work. But here no need to unmount. Here it is an online activity. That means without unmounting that LV, we can extend that LV. That is the advantage of LVM, one of the advantage of LVM. Okay. What is decreasing means we will see later. Okay, but increasing an LV is an online activity. You can do it in online. That means no downtime. Downtime means no need to down that system. Okay, okay, no need to down that system. Okay, so how to do that one? Check the current size of LV. We know how to check the LV size is LVS or df-h command. After that we use command lv extend -l. Okay, if space is available, no need to worry. If space is not available, again we will extend by using vz extend. If space is available in vz, no need to worry. By using lv extend -l, additional size, how much we want to add, we need to mention it, and that lv name, simple. Okay, after that you need to resize the file system, because previously the file system was given to only 300 MB. Okay, now the file system we need to resize it, because it was changed to 1.5 GB now. Okay, so that's you need to check. Okay, and you need to mention the LV name, simple. We'll do it. Okay, check by using how many, the df-h. Oh, sorry. Okay, if you check it, the LV size is 291. That means approximately 300 MB as there. Okay, now I want to extend this LV to 1.5 GB. So 1.5, already we are having 300, so I need 1.2 extra GB. Okay, or simply it is 200 or 1.2 GB. 1.2 GB I want to increase it. So first check whether the space is available in VZ or not by using VZS command. Just now we have done that, so we are having 3 GB, so don't worry, we're having that much space. We can add it to LV. So for that we need to use the command lv extend capital. In real time you need to very careful while doing this. Here I am adding 1.2 GB, so you must mention plus here, plus 1.2 Z. If you don't mention 1.2 plus here, it will consider the entire size of this LV as 1.2. If you use plus, then it will add 1.2 GB to existing 300 existing this 300 MB, so that it will become 1.5 GB. If you don't do that, it will consider 1.2 GB. So already that will make a problem to us. Okay, that will cause some issue. And you need to mention that LV name /dev. Our LV name is vg1/LV path. You need to mention the path. Okay, my LV was successfully resized. Okay, you can use lv extend command, or you can use lv resize command also. Syntax is similar. Okay, next I need to resize this one. So for that the command is resize to fs, and the syntax is, look here, I have resized the LV name. Okay, of course you can mention that one slash stdev and vz1 slash lv1. Okay, you can do that one also. You can mention the size here also, resize the size. So, you will check that with the manual option, man option. Okay, now check whether the LV size was extended or not. LVS, look here, it was resized to 1.5 GB. Okay, previously it is just 291, that is approximately 300 MB is there. Now it was extended by using LV extend command. Okay, plus 1.2 GB is added, so like that. Okay, after that we have resized the file system. You must do this one. File system also, you have previously we have applied our file system to only 300 MB only, but it was resized to 1.5 GB. Now you need to resize that fs. For that you have used this command. Now it is entirely changed like that. Okay, like that you can use LV extend command to extend the LV. So to increase an LV, it is an online activity, no downtime was required. Okay, that's how we can extend an LV, we can extend VZ.